Hey everyone, thanks for joining us. My name is James Arachuri, and you probably know it's Tanmay Bakshi again.
Hello.
We're actually excited to announce a new series this year called Building the Tanmay Watson Made Simple series, where Tanmay is going to be taking you through a journey throughout this year on some of these awesome technologies and capabilities that we have, but from a real world's perspective and how to apply that.
Exactly.
And, Tanmay, quickly introduce yourself.
Sure. Hi there. I'm Tanmay Bakshi. I live just outside of Toronto in Brampton, Canada, and I'm an honorary IBM Cloud Advisor and an IBM Champion for Cloud. So as James said, this is going to be our first episode of many in the new Watson Made Simple with Tanmay series. We're going to actually be doing some regular episodes, and this year we're going to be having some special guests on the show as well. So I guess now, without any further ado, should we begin?
Yeah, and Tanmay, I would love for you to help me figure out how to solve my hunger. I'm really hungry right now, and I have a hankering for pizza. Can Watson help me get a pizza?
Definitely.
All right.
In fact, that's the point of this Facebook Live event today. So today we're going to be showing you how you can build a chatbot that could actually order pizza for you through a REST API on an iOS application. So basically we're going to have an iOS application where you can converse with IBM Watson through speech, and IBM Watson will actually be able to help you build your pizza and then order your pizza through a REST API. Now, just before we actually get into a demo, though, and before we actually get your pizza, let's talk a little bit about the technical side.
Okay, please.
Sure. So, to begin, the Watson APIs we're going to be using today, first of all, Watson speech-to-text for input, as you can see behind me. And so speech-to-text we're going to be using in order for the user to be able to speak to the application and have that converted to text that Watson Conversation can then understand, and Watson Conversation can then, of course, act as our chatbot, and then Watson Conversation can give output to the user using IBM Watson's text-to-speech. So that's how we're going to be giving output to our user through our iOS application. Of course, so as I said, this is an iOS application, so the language I've coded this application in is Swift. However, I do have a surprise, I guess you could say, at the end as to how I was able to integrate Node.js with this as well. So make sure you stay tuned to the end of the Alive event in order to see what I was able to do with Node.js and this application as well. All right, so now, finally, I think we're ready to actually start ordering your pizza using this chatbot.
Let's make this thing work.
All right, sure. So now let's get to the demo. So as you can see, what I'm going to do is behind me, you should be able to see my phone here. Okay, and so this is my phone screen being mirrored onto this television behind me. And so as you can see, this is a simple application that I've set up, and this is the UI for our chatbot. It's extremely simple. All we have is a text view and a button. The button will allow us to control the recording status of speech-to-text to see when speech-to-text is and isn't listening to me, and I'll show you how that works in just a moment. But of course, we've got an invisible text view on here as well, and this text view will allow us to see the input that we're giving Watson and the output that Watson is giving to us, along with that speech-to-text and text-to-speech input and output. Let's actually try it out. So let's actually start the conversation with Watson by saying something like, "Hello, Watson, I would like a pizza." So I have stopped, and as you can see...
Hi, what size pizza would you like?
All right, so
I'm really hungry. Can we do a large?
Sure, definitely. So as you can see, Watson asked us what size we want. So now James wants a large, so let's do... We would like a large pizza.
Large pizza. Got it. Any toppings today?
All right, so as you can see, it tells us that it's understood that we want a large pizza, and it asks us for the toppings that we would like. And so, let's just say that we've never been here before and we don't know which toppings are provided. So we can actually ask Watson Conversation, since we're in this context now, what are my options? And as you can see, now I'm done talking to Watson.
We have cheese, olives, pineapples, and chicken as toppings. You can have 3 toppings tops.
All right, so as you can see, Watson has responded to us, and it gives us those 4 different types of toppings that we can have on our pizza. Of course, in an actual chatbot, you would probably have many more options.
Yeah.
But in this case, since we're going for sort of like an example, we have cheese, olives, pineapples, and chicken as our toppings, and you can have maximum 3 toppings. So let's actually try out, maybe, I guess first topping is cheese?
Please.
Sure.
Gotta have cheese.
I'd like my first topping as cheese. Topping, sorry, but...
All right. First topic
Still understood it.
cheese. Any preference on crust size?
Okay, so Watson still understood what we said, even though our speech-to-text didn't exactly go
Nice.
that nice. So,
'Cause it
as
got
you-
the intent.
Yeah, exactly. It understands that intent. That's where that machine learning aspect comes in with Watson conversation. And then it asks me if I have any preference on crust size. But just before we go to that, let's actually specify our second topic.
Okay.
Sure.
Well,
so
I want some protein, so can we get a chicken on that?
definitely. So, I'd like chicken as my second topping. As you can see, now speech-to-text will understood what I said, and Watson...
All right. Chicken as your second topping. Any preference for crust size?
All right, so now I think we can get to crust
Yeah.
size. I think maybe
Try
we
to-
should go for normal.
Well, I mean, I'm trying to watch my carbs. Can we go thin crust?
Sure, let's try that out. I'd like a thin crust, please.
All right. Thin crust it is. Any sauce requirements?
All right, so speech-to-text luckily understood what we said, and so Watson Conversation has replied to us, and now it's asking us what we'd like to do in terms of sauce. So let's ask it what our options are here, and let's decide according to that. What are my options? Okay, and then...
You can have no sauce. We can go easy on the sauce. You can keep the normal amount of sauce, or we can add extra sauce.
All right, so Watson has replied to us. Now it gives us those 4 options in terms of sauce that we can have. So James, what would you prefer here?
Let's go easy on the sauce.
All right, so please go easy on the sauce. And so Watson says,
All right. We'll go easy on the
Nice.
sauce. Would there be anything else?
well, I mean, I think that's it for today.
I'm good. I'm hungry.
Sure.
I'm really hungry.
So am I. So this works perfectly. So that's all for today.
All right. Great. You will be able to pick up your pizza soon.
All right, so as you can see, Watson has sent in the order, and it actually shows us those final specifications of our pizza. The size is large, the crust is thin, the sauce is easy, topping 1 is cheese, topping 2 is chicken, and topping 3 is nothing. And that's the application I'm going to be showing you how you can code in today in a live coding session. But just before we actually get into that, I guess it's pizza time then.
Yeah.
So, we actually do have a pizza here, so that's good. Great, so this is nice, so we can start eating now since we're hungry. But now, finally, we can get into the technical part of this demonstration. So if I actually switch back to my computer here, as you can see behind me, we're going to start building a diagram of how this application actually works. Now, the first thing is that we've got a few components of this entire system. And so the first and most important ingredient to this application, I guess you could say, is our hungry user, in this case James,
Yes.
who is actually trying to order the pizza. Of course,
They
now,
just took my pizza away.
well, though, of course, we've got the application, which is going to help us order the pizza. Of course, we've got our Watson suite of APIs, which will actually help us have the application order the pizza itself and understand what the user is saying. But of course, the REST APIs will actually order the pizza itself and receive the specifications from our application. Now, basically, the way this works is, obviously, the user gives us some input to the application. Now, again, the application will be doing all of the orchestration here. And so the application takes this input, and once the application has input from the user, voice input, we can't just directly give that to conversation, unfortunately. So we have to convert it to a string. So what we need to do is we need to take that voice and we need to convert it to text by running it through text-to-speech.
Okay.
Sorry, speech-to-text. Speech-to-text will then take that WAV file of the user's voice, and it'll convert that into a string. That string can then be sent back to the application, and the application now has some input data that conversation can actually work with.
This is the thin crust, those types of stuff. Okay.
Exactly. Like, for example, when I would say, please go easy on the sauce, that's my voice. That speech-to-text then converting to a string, please go easy on the sauce.
Got it.
Which can then be sent to, and is sent to, Watson Conversation. Watson, and of course we are sending a little bit of metadata about the actual conversation context on how our conversation's going, what was said last, and so once we have that context in order, then conversation is going to return to us a response. Now this response not only contains what it wants to reply to the user, but it also contains some new metadata about the conversation, which is then sent back in the next request. So you'll actually see a bit more of that about how that logic works in the actual live coding session, but that's basically how that works. But then, in order to make sure that the user doesn't even need to read the screen, we send what Watson Conversation told us to text-to-speech. Text-to-speech will then synthesize what conversation is trying to say to the user, and that's sent as a WAV audio file back to the application. The application then plays that out through the iOS device's speakers, and then finally the user can have their output. The user will then continue this cycle over and over and over again, just as we did in the demo, until they're done specifying what their pizza will contain. And once that's done, of course, we call our REST API, which is going to actually order the pizza as it did today.
Nice.
All right, so that's exactly how the technical part of this application will work. Now, though, let's actually get into a live coding session where I'm going to show you how you can actually implement this code. But before we get into that, what you should do is you should actually head over to my GitHub page. So you should head over to my GitHub page. TanmayB123 is the username there. And there's a starter code for the first Watson Made Simple event. What you're going to do is you probably want to download that starter code, because as you can see behind me, it's actually completely blank. There's no code or any interface for this. But what it does do is I've already included these IBM Watson frameworks in this application, namely RESTKit, conversation, speech-to-text, and text-to-speech. And so that you don't need to install them from Carthage from scratch at this time, so that you can follow along with us. I'd recommend doing this because it's much faster. But of course, if you'd like to manually install via Carthage, your choice, you can do that if you'd like as well. Alright, so now though, we are actually ready to begin coding, but before we actually code, let's start with developing the UI of the application itself. Now the UI is, as you saw, extremely simple. We just have a text view and a button on screen. And so what I'm going to do is I'm actually going to drag on, first of all, a button from my objects controller here, and I'm going to label this button as Start, as you can see right there. And what I'm going to do is I'm actually going to have another text view as well. In this text view, and we're just going to drag this on screen, and this is going to be almost as big as the screen, but just before hitting the button. And basically, this text view, as you saw, will allow us to see what input we're getting. Yeah,
right?
exactly.
Okay.
We'll see that Watson conversation going on, what you're saying to the chat button, what it's saying back to you. But another thing you're probably going to want to make sure is that the user can't change anything that's in that text view, because we don't want them changing anything. This is just to show them what's happening. And so what you want to do is click on your text view, and in the attributes inspector, deselect editable and deselect selectable. So once you've done that, the user will not be able to edit or select any text in the text view. So that becomes really convenient, because then we don't need to implement keyboard hiding logic when they hit return, that type of stuff. So it becomes much, much easier. Alright, so that's really all we had to do for the UI. Extremely simple. Now though, we can actually get into the code of the application. Alright, so let's begin with viewController.swift. And this is where we're going to be doing all of the coding for this application. The first thing we need to start off with though is our imports. Now, in terms of imports, again, we are in this application recording and playing audio, and we're doing this via the AV audio recorder and the AV audio player. And by the way, for this application, I'm assuming you have some, at least little experience with iOS development through Swift, so it's much easier for you to follow along. All right, so now the AV audio player and AV audio recorder classes are accessed via the AV Foundation framework. So what we'll need to do is import that first. So right after import UI kit, you're going to want to type in import AV Foundation on your screen. And then you're going to want to import your Watson APIs so that you can actually use them in this application. So I'm going to be importing conversation, we're going to be importing speech to text, and of course we're going to be importing text to speech. Now once you've got all those imports down, you should be ready to actually start coding in your application. Let's begin with a few variables that are going to be used throughout this class. So if I go into my view controller class here, I'm going to declare some class level variables and constants. And let's actually begin with our IB outlets, which will actually let us communicate with our interface builder or our UI throughout this code. So I'm going to create a new IB outlet variable, and so this is going to be called, let's just say, start stop button, because as you can tell by the self-explanatory name here, this is the button which will allow us to start and stop our voice recording. Of course, though, we have to declare our text view, and so we're going to be calling this the conversation list, and this is of type UI text view. Once you've got those IB outlets down, that's all you need to do in terms of IB outlets. But we've got a few more variables that you're going to need to create today in order to create this application. So two of the most important ones, though, would be our AV audio recorder and our AV audio player. So let's create those. So first thing we're going to do is create a new recorder. So variable recorder, and set this to a new AV audio recorder. Of course, this is going to be a forced optional, so it's equal to nil by default. And of course, we're also going to be creating a player or AV audio player. Once you've got that down, you're done with your AV classes in terms of, or audio video foundation classes in terms of class level variables. Now though, let's start working with some conversation logic. Now the first thing in terms of conversation logic that you're going to need to take care of is your last context variable. As I said when I was explaining in the diagram of this application, what we're going to be doing is sending Watson in the first message no metadata about the conversation and also the user's whatever the user said. But then what happens is when Watson returns stuff back to us, it returns a variable called a context variable, and it also returns a response. So the response, we can of course show that to the user and give it to text to speech. But then what we need to do is in the next request that we send to IBM Watson, the next message the user sends, we need to take that last context variable that Watson gave us and send it back to it. And do that every single time to make sure that IBM Watson knows what, of course, is going on in the conversation and is able to reply accordingly. And so the way we can do this is by creating something called a last context variable. And this is going to be of type context, and this is going to be a normal optional. So by default, it's nil, and of course we're going to be passing this to IBM Watson conversation the first time as a nil object, so it'll know that there's no context, and this is the first time that we are, of course, sending a message to Watson from this application. Once that's done, though, there's a little bit more conversation logic left. And what we're going to do now, though, is we're going to create the variables that'll help you keep track of how your pizza is actually being ordered and the structure of the pizza order. So let's actually take a look at how that will work. So what are the things that the user can change about the pizza? Well, they can change the size, the crust size, the sauce, the topping 1, 2, and 3. Right? So all we need to do is create variables for each one of those. So I'm going to create a variable called size, empty string, of course crust size, again empty string. We're going to create something like sauce, empty string again. We're going to create the topping 1 and topping 2 and of course topping 3. Once we've got all our toppings down, we're done with all of our conversation logic, and there's just one last constant that we need to create in the class level scope. And what this would be is our output file URL. Now, this URL will actually be the URL to the file that our AV audio recorder will record files to, and Watson speech to text will grab audio from. The way we're going to do this is we're going to create a new output file URL constant here. And this is going to be equal to a new URL, okay? And that we're going to be using the file URL with path initializer here. Now, this takes a string, and in order to get this string, we're going to run the ns search path, and then wait for it to fill out, and then ns search path for directories in domains function. And this will return an array of strings. And so we're going to ask it to find the document directory through the default user domain mask, and of course we're going to ask it to expand the tilde. Now this returns an array of strings, so we're going to get the last element by forcefully unwrapping the last element in this array, and then to this we will append /watsonaudio.wav or .wav, or wave technically. And so now this is the URL that the recorder will actually record your audio to whenever you click on start, record your audio, and then click on stop. Of course, though, this is also the URL that speech-to-text will grab your voice from when it's trying to understand what you said. And that's what that's what this constant, will be doing. And that's what we had to do to initialize basically this entire class and have our base variables down in order to get started with the actual code. But to begin with our actual code, though, we need to start off by initializing our AV audio recorder. And the way we can do this is by going into our viewDidLoad function, and over here we're going to be, of course, initializing our AV audio recorder so it's ready to record some audio. So the way we can do this is by, first of all, we need to create a new session, okay? And I'm going to create a new AV audio session in a new constant, and I'm going to be getting a shared instance, meaning the default instance of an AV audio session. Once that's done, I'm going to create a new variable called settings, and this is going to be a new dictionary of type string any object. And of course, this is going to be a blank dictionary by default. But then what we're going to do is we're going to go to the settings dictionary, and we're going to be setting the AV sample rate key to a new NS number. And this NS number will be using the float literal initializer, and we'll be using 44100.0 as our number here. Again, you don't exactly need to know what this means. We don't really care about that. All this is doing is it's initializing our recorder so it works with Watson speech to text. That's all we care about right now. This is not related to Watson in any way, though. But then we're going to go back to our settings variable, and we're going to be setting the AV number of channels key to a new NS number. This time we'll be using the integer literal initializer, and this will be equal to 1. That's it, just one channel in our AV audio recording. Once that's done, though, well, I'm going to be a little bad here, and I'm not going to implement error handling because I want this to be as simple for you as possible. But in your applications, I would highly recommend you implement error handling because, of course, it's important and you don't want your application just crashing. And so I'm not going to be implementing a do-catch statement here, although you could in your applications. Right now, I'm going to forcefully try to do all of this. So what I'm going to do is I'm going to forcefully try to set the session category that we created. I'm going to be running the set category function, and what I'm going to be doing is I'm going to be setting this to AV audio session category play and record. Once that's done, I'm also going to forcefully try to set the recorder to a new AV audio recorder. I'm going to be initializing this new AV audio recorder, and of course I'm going to be using the URL settings initializer right over there. The URL will be the output file URL because this is where we want our AV audio recorder to save the recordings, and settings will be the settings variable that we had just created. Once that's done, though, we're going to tell the recorder to set metering enable to true, and then finally what we're going to do is we're going to set the recorder to prepare to record, and once we're done preparing that recording, we are done initializing our recorder, and we can finally get to working with Watson.
Nice.
Yay. Okay, let's get to that now. So now you can get out of your viewDidLoad function and you can create a new IB action. And we're going to create a new IB action function, and we're going to call this start stop recording. Now, this is actually the function that's called whenever you click that start/stop button. And so inside of here, we're going to create a new if statement, and we're going to check if the recorder is recording. But if it's not recording, which is what that little exclamation mark at the end over there does, if it's not recording, then what'll happen is it'll run some block of code. And this block of code, what it'll do is it'll first of all make sure that first of all we create a new session, which is our AV audio session. This is our shared instance, by the way. And then what we do is we forcefully try to set the session active by doing session.setActive true. Once that's done, and again, I'm not implementing error handling, that's not good. You should do that in your applications. But then, once I'm done that, I tell the recorder to record by running recorder.record, that specific record function. And once that's done, we're ready to set the start/stop button's title to stop, because now we are recording the user, and when they click on stop now, it'll stop recording them, and of course we're going to be using a normal UI control state. And so that's what we're going to be doing in this block. But what if the recorder was recording and the user just clicked on stop? Well, in that case, we actually want to start using IBM Watson. And so now let's implement that. So let's actually put an else into our little if statement here. And let's actually start implementing what happens if the user was recording their audio, and now, of course, they get to send that audio to IBM Watson and continue those steps in the pipeline. Now, the first step we have to work with is speech to text. And in order to do that, we actually have to have that audio file in a real WAV file on in the documents directory. And the way we can do that is by telling the recorder to stop recording by saying recorder.stop over there. Once that's done, what I'm going to do is I'm going to get a new AV audio session, again our shared instance, and I'm going to set active to false. Once again, I'm going to forcefully try this. Once that's done, though, finally, we can actually start working with Watson, and specifically speech to text. So let's actually create a new speech to text constant here. And since we've already imported speech to text, I can actually create a new speech to text object, and I can initialize this with my credentials. And since I already have some credentials and I don't need to create them in Bluemix, what I'm going to do is I'm going to paste them into this application. And these are my speech to text credentials here. And this is what we're going to be using in order to, of course, understand what the user's saying. Once that's done, we're going to actually create a new settings variable, though, and, well, basically, the speech-to-text service needs to know what it's going to be given. Is it going to be given a WAV file and some other sort of file, like some other sort of audio file? In fact, you can actually check this enumeration. Are you giving it a BASIC file, an FLAC file, an EMULA file, an OPUS file, or a WAV file? So there are many different file formats that speech-to-text works with, but in this case, we're using WAV, so we're going to create a new recognition settings object over here, put that in the settings constant, and the initializer we'll be using for recognition settings is the content type initializer, and we're going to be using .wave as the content type. Once that's done, though, we are ready to go to the speech-to-text constant that we created and call the recognize function on it. And we're going to be using this initializer right here, the one that's really short, the shortest initializer, but, of course, this takes the audio as URL and not data. Once that's done, the audio we'll be giving it will be the output file URL, and it'll automatically grab the data from that URL. The settings will be the new recognition settings that we just created. And once that's done, we'll be creating a success completion handler. And of course, the one parameter we'll be taking in this completion handler would be the speech recognition results. And we're going to be calling this the results variable. Now, inside of this completion handler, we're going to be putting in some code. And the first thing we want to do once we receive some text from speech to text is show the user that they have said something. And as you saw in the demo, it says, like, for example, I said, please go easy on the sauce. And it said, please go easy on the sauce. It showed me what I said. And so the way we can do that is by appending that to the text view. But when this code is called, we will be in a background thread. And that means we're not in the UI thread. So we've basically got this main thread, we've got a few more threads here, and we've deviated from the main thread, which is our UI thread, to another thread, and this is a background thread. And that means that this code is going in parallel with our UI code, so we're not freezing the UI while we're waiting for speech to text. But the only thing is, for our background thread, we can't change the UI since we're not in the UI thread. So what we have to do is we have to just fork back into the UI thread, and we actually have to change that text view and get right back to our background thread. So the way we're going to do this is we're going to go into iOS's operation queue, and we're going to go to the main operation queue, which is our UI thread. And so what we're going to do here is we're going to add an operation. And the code for this operation is actually quite simple. We go to the self conversation list, which is the text view that we just created, and then we set its text to this, and I'll tell you what this does in just a moment. So we set it to the text that was already there, and then we add U space, and then we add what you just said, and then we add a new line. So basically, this code over here, this line of code that I just added, will append what I just said to the microphone or to speech to text onto the screen, so I can see if speech to text actually understood me correctly. That's what this code over here is going to do. But then you're going to go after the ending bracket or brace for your operation queue added operation. And once you're after that little line of code, we're ready to start working with conversation. This is actually quite a simple service to use, speech to text. Now, though, we get to work with conversation. Now, the way we can do this is by creating a new conversation context, and this is going to be equal to a new conversation class. And of course, as I said, we can initialize this with my own parameters or with your your own credentials. And so what you're going to do is you're going to fill them out in this initializer here that you've got for the conversation class. However, since I've already got my credentials ready, I'm going to just paste them in from the other screen. And as you can see, those are my credentials there. Of course, though, we are also specifying the version of the conversation model to use, and so this is, as far as I know, the latest model in existence here. And so that's the one that we're going to be using. Finally, though, once that's done, all we need to do is create a message request. And this message request is actually going to help us send a request to the conversation service. So let's create a new MSG request here, and let's set this to a new message request object. And we're going to be using the longer text string initializer over here. And once I put in that initializer, I'm going to be setting the text to results.bestTranscript. And this is the best transcript that speech to text believes that it could provide of the user's voice. Once that's done, I'm going to be giving it no alternate intents, but then you see that there's this little context parameter that it wants. And so this is actually going to be equal to self.lastContext. But you must be wondering, though, last context is by default nil. Why would we want to pass it here? Well, you're right in a way, but the message request actually takes an optional context specifically. And so what happens is if last context is nil anyway, it's just as good as us saying nil to it directly. However, if last context is full of some metadata about our current conversation, then of course that will be sent over to the message request, and that can be sent to conversation. So the logic behind that you'll understand in just a moment when I add in the next few lines of code that'll actually update that metadata, but you'll see that in just a moment. Of course, I'm going to be giving it no entities, no intents, and of course, no output as of right now. Once that's done, though, finally, what we need to do is call the message function on conversation. And so we're going to be using the longer initializer down there. I'll paste in my workspace ID in just a moment. Message request, we're going to be using the message request that we just created. I'm going to, again, not implement any failure initializer. You should be doing this in your applications, but I'm not right now. But then, in terms of success initializer, I am, and of course the one parameter that we'll take in this completion handler will be called response, and there will be some code inside of this message completion handler here, and so I'll tell you what exactly that code will do now. So the first thing we need to do, though, is update the conversation metadata. And the way we can do this is by setting self.lastContext to the response.context. So basically, the context that Watson returned to us, we're putting that into the self.lastContext variable. And the next time we send a message to conversation, this message request over here will actually pass that into the context, and then this will repeat and repeat and repeat until the user's done ordering their pizza. And until then, conversation will actually keep track of the pizza specifications. So that logic might seem a little bit confusing, but again, if you've worked with conversation before, I'm almost sure that you'll understand exactly what this means. And so then, once you're done that, you can actually start working with some entity and intent logic. So let's actually begin with our entity logic. So let's create a new response entity constant over here, and we're going to be sending this to the response entities, and I'm going to be getting the first from this array of entities. Now, of course, there's always a possibility that there's nothing in the entities array, and so first is nil, and that's why it's optional. And so that's why we're storing this in a temporary constant right now, and I'll be talking about how we'll, of course, find the actual output of entity in just a second here. So after that, though, we're also going to do the same for the intent. So response intent is equal to the response intents, and again, this is an array, and we're getting the first from this array. Again, could be nil, and this is why we're going to be putting some if-let statements here. So now let's put an if-let statement, and let's see if let entity is equal to response entity. This means that response entity actually has something inside of it and is not nil, and so if it's not nil, that value will be put into the entity constant, and the code inside of this block will be called. And so then, inside of this block, we can use that entity. And the first thing let's do is let's extract the entity's label by doing entity.entity. And then let's extract the entity's value by doing entity.value. Then let's check if the entity label over here was equal to topping. If the entity label is equal to topping, well, I have to pause right here. There's a line of code we're missing, and I purposely missed that out. And the reason being, I have to explain some sort of logic to you. So if you take a look at the screen now and just really concentrate on that screen, I'm going to put in a few comments here. And so as you can see, basically what the logic is behind this application is that topping numbers are handled by intents and specific toppings are handled by entities. What I mean by this is, let's just say you say, I'd like my first topping as cheese. Or, you could phrase this however you'd want, but this is basically what you'd say. This is what you'd intend to say. The intent here would be topping 1, but the entity would be topping cheese. And so if we were to combine these, we would know first topping cheese. And so that's what we're trying to implement in terms of logic. But there's one more thing that you should see here, though, which is that let's just say you were to say, I'd like cheese. You wouldn't say, I like my first topping as cheese. Then who knows what the intent will be? We don't know, because Watson conversation hasn't been trained to understand that. But
could be a cheese crust, right? If that was one of the opportunities.
Exactly. So, you wouldn't know what this would mean, but our intent would know that this is topping cheese because it sees the word cheese inside of here. And so what's happening here is we get confused. The code gets confused and it doesn't set your first topping to cheese because it doesn't know which topping it should be. Should be your first, second, or third topping. Doesn't know. But then let's just say you say, I'd like my first topping, which I'm not sure why you would say something like that, but if you were to, then your intent would be topping 1, but there would be no entity because there is no topping mentioned in the sentence. There's the word topping, but you're not specifying chicken, cheese, olives, or pineapple. You're not specifying any of that stuff. So entities don't come into account here. And so that's why that becomes a little bit more confusing. And so what we need to do is, before our if-let statement, we need to create a variable called topping type. And this topping type variable will be an optional string. And so the reason this is going to be an optional string is because by default we want this to be nil. Okay. However, if our entity contains a topping, then what we're going to do is we're going to set this to that topping. So inside of our new if statement, where we say if entity label is equal to topping, then what we do is we set, as you probably guessed, topping type to the entity value, not the label. And so, in this case, our label would be topping, but our value would be something like cheese. And then when we're handling the intents later, then we can see, okay, which number of topping were they talking about? Were they talking about their first topping, second, or third? And depending on that, we can, of course, continue and implement our logic. So that's how that works. And since we're on the topic of intents anyway, let's implement our intent handling. So after your if-let statement for the entity, let's implement the if-let statement for the intent. And so we're going to say if-let intent is equal to response intent. And if this is true, again, if response intent is not nil, then the value of response intent will be put into intent, and then this block of code will be executed. So let's actually say maybe something like intent. Oh, sorry, no, we have to actually check something first. So what we need to do is we need to create a new constant called contextual intent and set this to the actual string value of the intent, the actual name of the intent. And so then what we do is once we've got that down, we have to put in a few if statements, unfortunately, a lot of if statements. So the first one we're going to do, though, is say if contextual intent is equal to size small. Now, the size small intent means, as you probably guessed, the user wants a small pizza. And so we can say small pizza, and we can set self.size to small. Now, of course, we can continue this exact pattern for all the rest of the, I'd say, around 10 intents here. But, of course, as you can probably guess, that would take a lot of time. And I don't want to, of course, spend your time on the live stream right now. And so instead of spending your time, what I've gone ahead and done is I'm just going to paste in these if statements from another screen here. So I'm just going to copy and paste.
And for those wondering, we've provided this also via your GitHub.
Exactly.
So you don't have to worry about missing out on that. It'll be available to you to follow along.
Exactly. So right after this event, the actual final source code will be open sourced. However, though, the starter code you can actually find on GitHub right now. And if you'd like, you can actually follow along with us right now. Have any questions or issues, you can leave them in the live chat. James will be giving me some more questions later. Of course, we're going to be doing a great Q&A. But let's continue. Now, as you can see, we're getting an error. And I made this error on purpose. But why? Well, there's a simple reason. I need to explain some more logic to you. So what's happening here, we're getting an error because log pizza is a variable that hasn't been defined yet. But what's log pizza? Well, when the user's intent is done, and that means they're done ordering their pizza, they've finalized their specifications, then we want to take the actual pizza specifications and print them out onto the screen for the user to see, just as you saw in the demo, how at the end it said size large, sauce easy, crust thin, topping 1 cheese, topping 2 chicken, topping 3 nothing. When it said that, it was because of the log pizza variable. And the log pizza variable is saying, okay, the next time we go into the main operation queue, we're actually going to paste out all of those pizza specifications onto the screen. And so the way we're going to do this is before our if-let for the intent, we're going to create a new constant, or variable, called log pizza. And this is going to be equal to false, and Swift will type inference this as a Boolean. And so after your if-let, though, you can actually go back into the main operation queue in order to change the UI. We're going to add an operation here. And here we're actually going to do a few UI changes. The first one is, again, as you saw in the demo, when Watson replies to us, it doesn't just say out what it said. It also says Watson : and then says what Watson said. And so basically what we're going to do now is we're going to say, okay, we get to the conversation list, self.conversation list, and we append to its text, again, another row that has what Watson conversation replied to it. So response dot output dot text dot first. And of course, we're forcefully unwrapping. You should be implementing error handling in your actual application, though. And so this will actually add out what Watson replied to the user in this onto the text view. And of course, I forgot to put dot text here, so that's a must here. Alright, so once you've got that done, then we put in an if statement to see if log pizza. And if log pizza, then we want to put all those pizza specifications, as you saw, onto the screen. And so, quite simply, all you need to do here is do something like maybe copy this line of code here, paste it in and change this to size, and change this to self.size. And again, since we have quite a few pizza specifications, and this is still a small application, I'm just going to paste in those other pizza specifications from another screen of code. As you can see, these are all of our pizza specifications, so it'll print out the size, crust, sauce, topping 1, 2, and 3. Once that's done, though, after log pizza, you're finally ready to work with the last, final step in the pipeline. And this is your text-to-speech service. And finally, after this, you can actually go ahead and order some pizzas using this bot. So, all you need to do in order to work with text-to-speech is create a new text-to-speech constant, set this to a new text-to-speech object, and again, I have my own credentials for this service, so I'm going to be pasting those in right now. As you can see here, I've got my credentials here, and then what I'm going to do is, quite simply, no message request or settings or anything to be done, just do text-to-speech dot synthesize, use the smaller initializer, give it the text as what Watson returned by going to the response, getting the output, getting the text, and then of course getting the first in that array. And then your success completion handler will contain an object of data, and just call this audio, for example, and then you have some code. Now, I'm going to be pasting something in here. Let me show you this. So basically, what I'm going to do here, and this is actually pretty important, is I'm going to get a new shared instance of an AV audio session, and I'm going to be overriding the audio ports to make sure it plays the audio through the speaker. But what does this mean? Well, it's quite simple. So with an iPhone, specifically an iPhone, not iPads don't do this, iPod Touches don't do this, only iPhones, by default, when you tell them to play audio, they'll actually play it through the earpiece, so the audio will be very dim, and so you won't be able to hear anything. But we want really loud audio so you can actually hear something. And so, what's going to happen is we need to actually override that earpiece and go directly to the speaker. But there's a little problem. Now, let me actually tell you a quick story here. So while I was at IBM Developer Connect 2016, I actually had my Tanmay application, which had speech-to-text as well, and it would use codes, or text-to-speech, sorry, and it used code similar to this. And so, one thing you must note here is that this won't just override the earpiece. It'll override the headphone, the HDMI, Lightning, everything. And so you will be able to hear the speaker, but the audience won't be able to hear the speakers at all. So you might want to stay careful of that. So if you'd actually like to play this to speakers or headphones or something of that sort, you'd want to implement your own logic for overriding specifically the earpiece, going to the speakers if there are no headphones or anything else plugged in. So you're probably going to want to implement that if you want that functionality. Alright, so once that's done though, we can actually play our audio. And the way we can do this is by going to the self.player, as you know we created in the beginning of this live event. And we're going to be forcefully trying to set this to a new AV audio player. We'll be using the data initializer, and we'll be using the data that Watson text-to-speech returned to us in the audio variable. Once that's done, we're going to be telling the self.player to prepare to play, and then self.player to actually play. And from there, you are done coding in this application. But one last line of code. All you need to do...
I'm hungry.
I know, but just one last line of code, I promise. And then, so all you need to do is set the start-stop buttons title to start, and then set it to a normal UI control state, and you are done coding. All you need to do now is go back to your main.storyboard, connect the IB outlet to the text view, and of course the button. So I've connected my IB outlets to the text view and the button, and then I connect my IB action from the button to the view, and then we are completely done. Our button now knows how oh, sorry, I didn't connect the IB action properly. Anyway, so now our button knows exactly what to do when it's clicked. Our text view knows what output to give when it's done. And of course, this application is ready to be tested. Would you like to test this out now?
Please.
All right. So what I'm going to do is I'm going to, first of all, connect my phone to my Mac, because we can't do that. We can't test this application out without connecting. So there's going to be a little bit of lag between putting this phone on screen. So what I'm going to do here is I am going to run this onto my device, and then we will... so it's going to run on my device. We'll be able to see it on screen in just a moment. Unfortunately, these Lightning to HDMI's don't allow you to transfer data through the Lightning port that they give you, only power, so that doesn't work.
Come on, Mac. Or Apple.
Okay, so then we can continue. I'm going to plug this back in. As you can see on the TV right now, we've got my phone. And there we go. As you can see, now this is the application that we just coded in live. Let's test it out. Hello. As you can see, it says, or at least should say in just a moment here. Oh, one thing I forgot to do in the code is we have to paste in the workspace ID for conversation, of course, or else how will it know where to go? So what we have to do is go back to the code. So you already know where this is. I've already shown you this. I'm just going to paste in the conversation ID, and then we will switch back to the phone. So workspace ID right there. All right, so then we just run this right back onto our phone, and then we should be able to test out our application. All right. Run the app, and in just a moment, it should run onto my phone, and then you'll be able to see it on the screen once I plug it in. All right. We've got this running, and switch over. So you can see here, it shows my phone, and now we can actually test it out. Hello. So in theory, the recording works fine.
What
Sweet.
size pizza would you like?
All right, so Watson is able to reply to us using text-to-speech. It's able to, so we've seen that the recording works perfectly, speech-to-text works perfectly, conversation works nicely, the text view works nicely, and of course text-to-speech works perfectly as well. And this is our live coded-in application. I'm not using the older application right now, and that is how you can implement your own little pizza ordering chatbot that'll actually call a REST API when it's done ordering the pizza in order to actually get your pizza. All right, so I guess it's pizza time again. But now, just before we end off with this application, as I said, I have another little surprise, I guess, with Node.js and this application.
All right.
So let's take a quick look over here, back at our presentation here. And so this is our system before, or no, we have to switch back to the Mac. This was our system before, all right? Right over here. And so this allowed the user to order a pizza using the application. But there are a few problems with this. First of all, you have to keep, updating the software according to the newer Swifts that come out. Of course, we have to have, the user has to have an iOS application specifically. They can't have another type of device. Like they can't order it from a flip phone, for example. And so there are just a few problems with how this is implemented, which can't really be solved by creating more and more and more applications for different types of devices. And so, the way that I've decided we can combat this is by, instead of using my own custom application, we use Twilio. And so Twilio will allow us to actually order these pizzas through SMS. That's right, we can actually use Twilio in this case, and through that means we could really order a pizza from a flip phone, we could order it from an iPhone, really anywhere where you can send an SMS from anywhere around the world. And so, now, as you know, with SMS, speech-to-text and text-to-speech don't really come in because, of course, we have direct SMS. So those have to go. So those services are no longer in use. Now, of course, though, we can't have Twilio directly communicate with the REST API and conversation. So we need to implement a Node.js server in between, and Twilio will contact the Node.js server whenever it receives a request from the user, and then the Node.js server will send that to conversation. Conversation will reply to the Node.js server, and it'll send that back to Twilio for the user. And of course, once the user is done ordering their pizza, the Node.js server will actually send that request to the REST API in order to have the REST API order their pizza. In fact, now let's take a look at a demo of how that itself can be implemented. And so now if I just open up my messages here, I'm going to compose a new message, then I'm going to switch over to my phone, and then while it switches over, I'm going to go into my Linux box over here, and I'm going to start a Node.js script, if it'll load, that is. sometimes the internet doesn't want to cooperate with you. So just give it a moment. So as you can see, this is behind me, but it might just take me a moment here to set up the actual Linux. So basically what I'm going to be doing now is I'm going to be opening up, or opening that Node.js server that comes in between the Twilio conversation and the REST API. Alright, so it should work technically. So now as you can see behind me, we've got my phone once again, my text message, and so I'm actually going to be composing a new message to my Twilio number that I've got set up. And as you can see, what I'm going to do is, again, just like we said to my application, I'm going to say hi to Twilio, and it returns with hello, what size pizza would you like? And of course, from here, we can continue our conversation, of course, just like we did last time. We'd like a large pizza. Sure, what toppings do we have? Just to prove, though, that this is actually keeping in track of the context and the flow of our conversation, I can ask it for the options, which otherwise it wouldn't be able to tell me about the toppings unless I was keeping track of the conversation and the context, which it has. And it says, we have cheese, olives, pineapples, and chicken as toppings. You can have 3 toppings tops. And from here, of course, I can continue my conversation with Watson, and I can continue to order my pizza from my SMS. And the best part is, though, that this will actually keep track of each phone's context variable independently. So you could have 500 people messaging it at once, and each one would remain separate, and it wouldn't get those orders mixed up ever. And so generally the implementation of this is very, very interesting. And in fact, you can see this source code on my GitHub page as well.
Nice.
All right, so that's what we had for this Facebook Live event today. But just before we go, though, we would like to do a quick Q&A, but one more thing is, though, that I'd like to say, first of all, a few conferences of IBM's. First of all, we've got Connect 2017 here. So Connect 2017 is going to be a conference all about IBM Watson. So this is going to be held in San Francisco from February 20th to 23rd. It's going to be a really interesting conference, so I'd recommend you check that out. But of course, apart from that, we've also got Interconnect 2017.
Which you'll be at, right?
Exactly. I'm going to be presenting at Interconnect 2017. It's going to be held from March 19th to 23rd in Las Vegas. So I'd recommend you check that out as well. Might even be interesting to meet some of you at Interconnect.
He'll be doing a book signing.
Hopefully, yes. So maybe. Let's see. So apart from that, of course, we've also got Amplify, which is going to be held almost at the same time as Interconnect. Again, Las Vegas, March 20th to 22nd. So of course, again, all about IBM Watson and IBM Bluemix, and basically how you can combine things like cloud and cognitive to your application's advantage.
Now, before we get to questions, can you pull up like your contacts or where they can
Definitely.
follow you on the social media environment?
Sure. So as you can see here, this is my contact information. So this is my GitHub as well, if you'd like to see my open source projects and the code for this application. Of course, my YouTube, email, Twitter, and LinkedIn. But of course, though, you can actually, also this is my book, Hello Swift, that I've written, Hello Swift, iOS app programming for kids and other beginners. And of course, you can actually pre-order this online on the publisher's website and many other bookstores as well, if you'd like to. And of course, you can actually just search up Hello Swift and pre-order that if you'd like. All right, so now I guess we can actually start the Q&A. Of course, our pizza was ordered, so that's nice. Thank you. So let's begin with a quick Q&A.
All right, let's see what we got. All right. So Tanmay, while I'm looking for questions, why don't you get them interested in like how you got started with Watson?
Sure, definitely. Well, the way I actually got started with Watson is actually quite interesting and quite coincidental. So what happened is around 1.5 years ago, I was really interested in general programming, really. And so what happened is actually this was in November, just before November of 2015. I was really interested in things like programming in general, and so I was on YouTube. I was creating YouTube videos, and so in my recommended pane, I actually saw a documentary about the smartest computer in the world, and I was like, okay, what's this? It was a 42-minute documentary, and it highlighted exactly how Watson was able to play Jeopardy, how it learns, what machine learning is, what AI is, and I was just so so interested by all of this. And so I was immediately hooked to IBM Watson. And so I couldn't resist myself but to see what IBM Watson is nowadays. And I was absolutely thrilled to see that Watson actually provided things like developer APIs. And so what happened is I actually started working with those developer APIs. My first API was Retrieve and Rank that I used. So it was generally very interesting how I got into IBM Watson. And of course, though, apart from that, I actually released my first IBM Watson video in November of 2015. And so, of course, I actually presented my very first Watson application at Interconnect 2016, which I had developed called Ask Tanmay, which is an NLQA system. So that's how I got started off with Watson.
Great. No, Tanmay, are there any of the services that you enjoy most from the Watson APIs?
Well, I actually got asked this, I don't exactly remember when, but I got asked this a lot. And so what I have to say there, though, is that I don't necessarily have a favorite Watson API. But the reason being here, though, is that they're all completely different. They're all good in their own use cases. But if you were to say the one that I find would be best for most use cases, really interesting and really fun to work with, I'd say visual recognition and the natural language classifier would have to be. And so the only thing is, though, things like Retrieve and Rank, Natural Language Classifier, they have such different use cases that I can't really compare them with each other and see which one's better necessarily. But in terms of interestingness, I think visual recognition and the Natural Language Classifier take the cake there.
Nice. What projects do you have working on right now that you maybe are interested in sharing with the team?
Well, I am actually working on quite a few projects. Most of them are quite secret for now, though. Of course, I am also working on a lot of projects to make the kids and their parents' lives easier. Of course, I'm working towards helping people with disabilities as well, which you'll see more about this type of stuff at Interconnect 2017. So again, that's why I'm saying you might just want to check that out as well.
One of the questions I see is
Yes.
regarding the APIs from Watson's. If someone was to get started,
Yes.
what would you recommend for someone to get started with Node.js if that's their programming language of preference?
Sure, yeah. In order to get started, like the Watson API to get started with Watson, I'd say the natural language classifier. The reason is because it's extremely simple to train, requires very, very little training data. So if you're not like a data scientist and you don't have a lot of data available, you don't have like an abundance of data, natural language classifier is great to start off. And so it just it trains very quickly, trains nicely, and it's accurate. So I believe that the natural language classifier is a great starting point at least. And from there, though, and it also has a lot of use cases, so you won't have trouble like deciding, for example, what example you might want to create. But apart from that, if you've already experimented with the natural language classifier and you're looking for a little bit more challenge, next I'd recommend the conversation service, because again, it's practically the natural language classifier and dialogue combined. Dialogue already wasn't really hard to use. Natural language classifier, extremely simple to use. Combined, they're really powerful and simple to use, and of course provide a lot of use cases. So natural language classifier and conversation would have to be it.
So some of the other things that we had, so some people, someone said, what if the web services stop supporting the API? Do you jump onto another language?
Well, okay, so, sorry, could you repeat the question?
Yeah, I don't know if it came out right.
Okay.
It says, what if the web services, well, actually, I had one, because as they saw you were having to manually enter things.
Yes.
Right?
Okay. Yeah.
How would you want to work around that so that way, is there a way to leverage the WebSockets?
Exactly. So speech-to-text, the Watson speech-to-text service, and in fact the Watson speech-to-text Swift SDK, which I'm using in my application, actually provides support for WebSockets in their applications. And so what happens is, like for example here, since I didn't want to, of course, complicate all of this and show you how to do things like WebSockets with this, what I did is I created this very, very bare-bones and simple application where we've got this recorder that records a WAV file, and that WAV file is sent as speech-to-text. But what you could do is you could have this WebSocket that would, of course, listen to you and stream transcripts back to you as you say them. So like as you were to say a sentence, each word would be sent individually back to the application and added to the text view. And it would automatically stop right as you're done speaking, and it detects that you're done speaking. And so, of course, Watson Speech-to-Text does actually provide that support. It's just that I haven't implemented it in this application due to simplicity. I wanted it to be as simple as possible for you to be able to understand the concept behind it.
So I want to ask, you've done about a year now with us, right?
Yes.
When we first met each other, found you online.
Yes,
and
actually.
we interacted that way, and we've been brothers ever since, actually. A lot of trips and journeys. But someone want to say that why did you go with like Watson from IBM's standpoint versus, I don't know, you've got Azure and you've
Yes.
got AWS or Google?
Well, there are actually quite a few reasons, and I actually get asked this quite often. The reason I'd say, number one, that I prefer IBM Watson over something like Google's Cognitive Cloud or maybe Azure's, as you said, would be that Watson, first of all, focuses a lot on natural language. That's that from the beginning, as you know, Watson's main goal was to understand and reason with natural language. And that's one of the reasons. And plus, Watson really allows you to work with your own data. Where, like Watson's visual recognition service allows you to use its own default classifier in order to do things like take a picture of a bird and it'll tell you there's a bird in the picture. But you can also create your own classifiers, for example, where with Google's Cognitive Cloud, you can't do that very easily, at least. You can, but it's not intuitive. It's just not, it's not as simple to do with Watson, and it's not as powerful in that context. Watson also provides a much wider range of services than any other cognitive cloud that I've seen, at least until now. And so that's really why I prefer Watson over most of these other services that are provided by other companies.
Let's see, some other ones is, so Tanmay, you just turned 13, or?
Yes, 13, October 16th, I turned
nice.
13.
I know you've had interactions with some of the other companies, especially regarding Walmart,
Yes,
right?
yes.
And I think Walmart asked you something specifically, like how did you learn so much about analytics, data science, machine learning?
Yes.
So I think it's a good question for a lot of people out there that are really hungry to grow their knowledge there. How can they follow in your recommendations?
Yeah, there's actually this one thing that I'd like to tell you. It's pretty much all about doing stuff. So, like, for example, when I found out about Watson, not only was I hooked to how these Watson APIs work, I was hooked to something else that came much before Watson APIs, which was the original Watson that played Jeopardy! I was very interested in how that worked, and I wanted to create my own NLQA system, for example. And so I created Ask Tanmay after many, many months of research and reading about, I'd say, 15 entire papers about NLQA systems. I finally got to one called Ask MSR, which is what Ask Tanmay is based off of, or Ask Microsoft Research, which they developed in 2002. But, basically what I'd like to say is, like, for example, the NLQA system I developed, that led me to finding out more things about machine learning. And finding out more things about machine learning led me to learn about things like neural networks. And once I had things like, oh, what's a neural network? Once I knew what a neural network is, and once I know what all of these different machine learning algorithms are, I start to get interested in, like, hey, what's a neural network? And then I do a few weeks of research on neural networks, and I start to find out how they work. And then in the process of learning how to use neural networks, I learn about some other concept entirely. And I get so interested, and it just, one thing leads to another, and I just, continually learn through basically learning one thing and then having that teach you another thing, and then continuing like that. That's usually how I like to, of course, learn with topics like machine learning, especially due to the fact that there is actually quite a bit of, there are quite a few resources online to help you do that. So I think it's really interesting basically, if you think about it, compared to other topics, machine learning doesn't have the most material online, but whatever material is out there is extremely useful. So it just turns out to, I found out about feed-forward neural networks, it takes me to convolutional, then recurrent, etc., etc. So just continuing in a cycle like that really does help me learn as much as possible.
Great answer. Unfortunately, we've got a lot of comments here, but we've got to wrap it up. So for anyone that has asked questions, like I saw the one on when do we, what needs to be installed on Windows 7 to start with Watson and Bluemix, and
yes.
another one says, what languages do you use for Watson programming? What are available?
Yes.
We'll respond back in the comments, so that way
Sure.
you guys, we make sure you get set in the right direction.
Definitely.
And please stay tuned, because Tanmay is going to be doing a lot more of these throughout the year. And again,
Exactly.
come to Interconnect next month if you can. To see Tanmay live again, further programming. He's going to be doing some other technologies, and he'll be able to meet you all, and you can ask some more questions there. Again, thank you again. I'm James Archeri, an IBM Cloud and Cognitive Technical Leader, and Tanmay, you are?
An honorary IBM Cloud Advisor and an IBM Champion for Cloud. Thank you.
Thanks, everyone.